Okay, now let us look at these questions. What is the frequency of the sound emitted by an open-ended organ pipe, 1.7 meter long, when sounding its fundamental frequency? Okay, so now let us identify, is this string or closed pipe or open pipe? Which cases is this? It is open-ended organ pipe. Open pipe. This is a open pipe. If open pipe, then the fundamental mode is this shape. It has two antinodes at both open ends. It has two open ends. So it has two antinodes at two open ends. If string, it has two fixed ends, so it has two nodes at the end. For open pipe, it has two open ends, so it has two antinodes at both open ends. If closed pipe, one closed end, one open end, so it has one node and one antinode. So for open pipe is two open end, so it has two antinode. This one is two node, this one is two antinode, this one is one node and one antinode. You see that? So remember the fundamental mode. Okay, remember the fundamental mode. So he asked for what? He asked for frequency. The question asked for frequency. This is the length of the whole pipe. This is not wavelength, this is just the length. And want to find the fundamental frequency. Fundamental frequency, that means for the first harmonic. The fundamental frequency is actually we call it the first harmonic. Fundamental frequency actually is the first harmonic, n equal to 1. Okay. Okay, so we want the fundamental frequency, the first harmonic frequency. First harmonic frequency is the fundamental frequency. So we just need to draw the fundamental mode of this open pipe. So how do we draw? This one, this is the fundamental mode of open pipe. Understand? Open pipe fundamental mode. Let's draw it out. Yeah, let's draw it out. I draw it out for you. Yeah. Okay. This one. So for open pipe, it has two antinodes because it has two open ends. Two open ends, so it has two. Okay, make it shorter a bit. Yeah. Okay. Yeah. So it has two antinodes. Okay, two antinode. It must have a node in between lah. Yeah. If two antinode, it must have a node in between. If two antinode, it must have a node in between. If it has two node at the end, it must have an antinode in between. It's inverse. Yeah, it's inverse. So how to draw? You must have two. This is the fundamental mode. This is the fundamental mode or first harmonic. Okay, so it must have two antinode in and then one node in between. So how to draw it? So this is the way. Okay, like that, and going this way. Okay. So this is the fundamental mode. And we know that from antinode to node, how far is it? It's one quarter wavelength. Just like example before. Okay, just like the example before. This one, remember this one? Need to draw this one. Where is it? Yeah, this one. Remember this one? Okay. Oops, sorry. This one. Okay. So from node to antinode is one quarter wavelength. From node to antinode is one quarter wavelength. From node to node is half wavelength. from node to antinode is 1/4 wavelength. So how long is this? Yeah, how long is this from node to antinode? Node to antinode is 1/4 wavelength. From antinode to antinode also half wavelength. You see that? From antinode to antinode is half wavelength. From node to antinode is 1/4 wavelength. Let's write down. This is 1/4 wavelength. Node to antinode, antinode to node also 1/4 wavelength. For the whole length is actually half wavelength lah. Yeah, from antinode to antinode, from antinode to antinode. Okay, from antinode to antinode is half wavelength. Okay, that's for the whole antinode to antinode is half wavelength. From antinode to node is 1/4. Node to antinode also 1/4. Also, it give you the length already, 1.7 meter long. That is the length. The length of the whole wire is 1.7 meter long. 1.7. That's a whole wire, whole pipe. Whole pipe. So also give you the speed of the sound in the air. So how to do this? How to find the frequency? Very simple. You just need to use the formula V equal to F lambda. So you can find the frequency from here. We already have the speed of sound V. The wavelength lambda you need to find from the length of the pipe. So the length of pipe is actually half wavelength. So from here you can find the wavelength. You put in the speed of the air and then you can find the frequency. Okay, so let's find the wavelength first. Let's find the wavelength first. Okay, so we know antinode to antinode is half wavelength. So this is the fundamental mode. The fundamental mode. If first overtone will be different already. First overtone you plus another half lambda. Get another shape of wave. Okay, so now we want to find the wavelength for this. The length, the total length of this one is antinode to antinode is half wavelength, or 1/4 plus 1/4 is half lambda lah. Okay, the length is half wavelength, half lambda. So the length of the pipe is 1.7. So my lambda is equal to 3.4 meter. Is it in SI unit? Yeah, already in SI unit meter. So already in SI unit, no need to change. Okay, and then the velocity also in SI unit, meter per second. Okay, so all unit in SI unit, so we are safe to substitute the value. So the speed of wave is 343 meter per second SI unit. And then the wavelength is 3.4, also in SI unit meter. Good. So what's my frequency of the wave? Let's find out. 343 divided by 3.4. It is 100.88 hertz. So it is 100.88 hertz. It's correct. It's correct. Okay, so that's my frequency. Very easy. V equal to F lambda, just a formula. What you need to know is, you must know about this lah. From node to node is half wavelength. From node to antinode is 1/4. From antinode to antinode is half wavelength also. Antinode to antinode is just like node to node. Understand or not? Half wavelength. So you need to know how to draw the fundamental mode frequency, fundamental mode drawing for fundamental mode shape of wave of the open pipe. Okay. Once you know that, you will know how many wavelength is this, how many lambda is this for the length of pipe. So the length of pipe is half wavelength. So from there you can find the wavelength. So once you know the wavelength already, you can find the frequency. using the formula V equal to F lambda. Understand? Very simple question. So still important is you must remember the first drawing. The first drawing of the string, close pipe and open pipe. Okay? The fundamental mode. Is it two fixed end with nodes or two open end with empty nodes? Two nodes or two empty nodes, and then, or is it a closed pipe with one node and one empty node? You must remember the first drawing. So from the first drawing, you can derive the following modes. You can derive the second harmonic, you can derive the third harmonic. Understand or not? So the important is still the first one, first drawing. Once you know the first drawing, you can derive the following drawings. Okay? Okay, so that's all for this question. Okay, thank you. Bye.